So if you're watching at home, 3 note cards on this page. They can look at the PDF. And then this page there is a 4th note card for chapter 5A. Okay, so we're going to look at some more exponential equations today, and there are 2 types we're going to look at today. One type we're solely going to do in the calculator. The other type I'm going to show you the by hand option and the calculator option, and you can choose wisely, whichever way you wish. So I have 3 to the x minus 2 equals 1/9 to the x. What is the challenge as far as the 3 methods I have up to this point? It's not an exponential equals a number, is it? It's an exponential equals an exponential. You could still use logarithms to solve it. It does get a little complicated, and again, that's something we're not going to do by hand today. However, the top 2 are very special problems that you could solve by hand, and I want to show you that. You could actually solve them by hand before you ever knew logarithms, just using properties of exponents. And then we'll talk about the calculator for the ones, like the bottom one, that you would have to use a logarithm and it would be very complicated. So we'll talk about that, and the bottom one we will just use the calculator. What do you know about 3 and 1/9? What is similar about those things? Aren't they a power of the same base? 1/9. Could I rewrite it as a power of 3? What is 1/9 if I wrote it as a power of 3? Good. 3 raised to the negative 2. Do you all agree that that is completely equivalent to 1/9? What do you do when you have a power raised to a power? What's the property for that? You probably have a note card really close to you that tells you what to do there. What did you say, Bailey? Oh, was it? No. Multiply. Very good. Were you the one that said that the first time, Jessica? Was that you the first time?
No, it's Jacob.
Oh. Any questions so far? If 3 to the x minus 2 equals 3 to the negative 2x, wouldn't x minus 2 have to equal negative 2x? Right? Which part? Which part, Jessica, can you not see? Any questions so far? I'll move it down a little bit. How far? Okay. Now, how do I solve this from here? Subtract x from both sides. And last step. Divide by which one? The negative 3. Good. And negative 2 divided by negative 3 is... And I could check that by typing x to the... I could type both sides of that equation in my calculator. Well, sorry about that. Still stuck.
You just use the side.
in Y1 and Y2? You could, and we're going to do that momentarily with one that you can't do by hand. Sorry about that computer glitchiness. Okay, any questions about that one? Okay, so the one at the right we can also do in our calculator. I mean by hand. We could do it in the calculator as well, which we'll talk about on one we can't do by hand. 2 and 8, do they share a common base? What? 2, good. 2 to the 3x plus 2. What is 8 as a power of 2? And that's where the 3 came from. 2 cubed is 8. Does everyone agree?
Yeah.
I knew what you meant. And when you have a power raised to power, what do? You multiply. So this is a very special case of exponential equations that where the left and right hand share the same base. But it's a very special case. Not all exponential equations are going to look like that. But if they come up, you'll know how to handle them. Allie and Shane, a lot of times these show up on the ACT. So for that purpose, it's nice to have that skill. You two are my only juniors in this class, right? I think so. In my 6th hour, I have 4. Am I going too fast? Now this one is also 2/3, totally coincidental. Just pick 2 problems with 2/3. Okay, the last one. There is a way to do it with logarithms, and I may show you that in the second half of chapter 5. Today I'm not even going to show you that part because it's quite difficult. And so for today we're going to use this one as our way to talk about how to use the calculator. So get your calculators out. Now, I am using this one because I can't do it by hand, or at least at this point I can't. But can you use the calculator for any equation solving? So all of the ones from yesterday, except for 26 and 7. Why not 26 and 7? Because they just had all letters in them. Speaking of, if I wanted to test how you could solve exponentials and logarithms by hand, how could I do it? So I'm putting all letters in it. So I can still test that, but most of the problems will be solvable in the calculator. So if you're on the test and you get stuck, what do you do? What I'm about to show you how to do if you have forgotten. Okay, so calculator's out. Go to y equals. In y1, type the left-hand side of the equation. What was the left-hand side?
7 to the power of x.
In y2, type the right-hand side, which was 3 to the x. I think it was 3 to there. I think so. Let's look and make sure. Yep. 7 to the x minus 2 and 3 to the x. The intersection, yes. What we really want to know is the x value, but we'll find the intersection. Skylar, the intersection of 2 graphs is always where those 2 graphs are equal. So we can solve quadratic before. Awesome. Okay, so now if I just push graph, what is the, hold on, window. Probably pretty on this one, you can probably see enough to figure out that you need to go up higher. Difficult to set your window. So I want to remind you of a skill you have.